So once again, we want to draw a picture, draw the beam, draw the force, FA, and that is at a distance of 0, FB, and that's at a distance again of 16, and we have our point source, P, at a distance of 11, in this case, 11 feet. And we also have something different in this one. We have this uniform load, and that is called W. So we've drawn our picture. Now we write down what we know. We know that P equals 500. We also know that W1, they're calling it 1, is 100 pounds per foot. So since it's 16 feet long, we multiply this by 16, and we get a W of 1,600 pounds, because it's 100 pounds per every foot, so it's 1,600 pounds for 16 feet. So now we do the exact same thing we did before. We do the sum of the forces, and I have a force here, 1 force, 2 force, 3 force, and a 4th force. So we have to now take into consideration the weight of the entire beam, and we also have to figure out the location. Well, if we have a uniform weight of an entire beam given with all these little arrows, the location is always right in the middle. So I'm going to draw that as a thick line, and I'm going to put a dotted line and do an 8. So I can see a distance. I have 4 distances, and I have 1, 2, 3, 4 forces. That makes it really easy if you identify things up front. So my sum of my forces, I have FA is going up, FB is going up, and my downward forces are W and P. So it has to equal the downward forces, which are W is 1,600, P is 500. So I have FA plus FB equals 2,100. That's my first equation, so I'm going to put a box around that. The next thing I do is I have the sum of the torques. Remember, torque is force times distance. So I have FA at a distance of 0. Always going to be 0 because that's where we start. FB at a distance of 16. Hopefully that sounds familiar because it's at the far side. It's 16 feet long. And this time, my downward forces, I have 2 of them. I have a W force of 1,600 pounds times the distance. Well, the distance is 8 feet. Uniformly located weights are always approximated in the very center, so it's always going to be an 8, or not an 8, but just halfway between the 2 sides. In this case, it's 8. Plus my P force, which is 500, and that was a distance of 11. And that becomes 0 plus 16 FB equals 12,800 plus 5,500. And let's keep solving this. If we add these two together, we get 18,300, and then divide by 16. And FB equals 1,143.75 pounds. So I'll put a box around that, and then we go back up to here, and we say that if FA plus, and now I know FB, so I can put the actual number in there, 1143.75 equals 2,100. Subtract this from both sides, and see that I'm writing everything out. It really doesn't take that long to show all your work, but it makes it a whole lot easier to see what's going on. When I subtract these, I get 956.25 pounds. And then I put a box around that too. So it's very easy to follow my work when I show all of my steps and I show everything that's going on. But right now what you can see is I have solved for FB. It's 1143.75 pounds. FA is a little smaller, and that should make sense because I have this point source that's closer to B, so it's supporting more load than A is. So that's an example of how you do these two problems. As you look at your assignments, you're going to find they may not be more difficult as you move on. In fact, number 3 simply has a uniform load. It does not have a point source. So that's a problem where you're only going to have 1 force just at 1,600 on the side. Problem number 4 has 2 point sources, and problem number 5 only just has a point source and not a uniform load. So you're going to find out just because they're numeric, 3, 4, and 5 doesn't mean they get more difficult. It just means they're different types of problems. You may even find that they're easier than some of these. So go ahead and give them a shot, and I need to see your work just like I've shown mine here.